Hi, this is Dr. Hall. We're going to go today through the answers to the questions in this section, C12.5, tests for negative ions. So these questions here. Name the reagents you would need, this is number one, to collect in the lab to test a sample of an unknown substance for carbonate, halide and sulfate ions. Okay, let's write something down here. Carbonate, halide and sulfate ions. So for carbonate, we're going to need any acid. We put some acid in with that and it produces carbon dioxide gas. And to test for carbon dioxide gas, we need some lime water. Halide tests, we need some silver nitrate solution and a bit of nitric acid. And then for the sulfate test, we need barium chloride and a bit of hydrochloric acid. And you'll notice that the nitrate needs nitric acid, the chloride needs hydrochloric acid. So when we're using these acids, we're putting the same kind of ions in. The acids are there to react with any carbonates that might be present, that would interfere with our test, and get rid of them. And we want to introduce as few ions as possible. So by using hydrochloric acid, we're only introducing Cl- ions, and by using nitric acid, we're only adding nitrate ions. We've already got some of those in our other reactant. So that was number one. Okay, question two. The unknown compound is a white solid. So that is going to suggest that it is probably belonging to group 1 or group 2. Most of the transition elements produced coloured salts. So group 1 or group 2, probably. The solution is acidified with nitric acid and silver nitrate is added. So those are tests. Silver nitrate is the test for halides. And we get a yellow precipitate. Yellow precipitate tells us it is an iodide. We have I- ions present. The flame test produces a lilac colour, and lilac means we have potassium present. So it looks like we have potassium iodide. Question 3. Write a word equation and a balanced symbol equation, including state symbols, for the following reactions: magnesium chloride solution plus silver nitrate, potassium carbonate powder plus hydrochloric acid, aluminium sulfate solution plus barium chloride solution. There are 4 marks for each of these. So quite a lot of pieces of information you need to supply. So question 3. 3A, we've got magnesium chloride solution plus silver nitrate solution. So magnesium is in group 2, so it's going to need 2 chloride ions to go with it in aqueous solution. It's going to react with silver nitrate. Silver forms an Ag plus ion. NO3 is a 1- ion. Again, that's in aqueous solution. Reacting. So what are they going to make? Well, we get a precipitate of silver chloride, AgCl. It's a precipitate, so we can say that's a solid. And then the other two ions are left in solution. We've got magnesium, which will be 2 plus. We've got our NO3 minus. So in order to make that electrically neutral, we're going to need 2 of the NO3 minuses to match the 2 plus charges on magnesium. And those are in aqueous solution. So, do we have balancing? No, we don't. We've got 2 Cl2s over here, only 1 here. We've got 2 nitrates here, only 1 here. So the way to balance that will be to put a 2 there and a 2 there. We've now got 2 chlorines, 2 chlorines, 2 silvers, 2 silvers, 1 magnesium, and 2 nitrates, 2 nitrates. Just see that on the whole thing together. There we go. In part 3b, we've got potassium carbonate powder and hydrochloric acid. Potassium carbonate, so carbonate, CO3 2 minus, and potassium is in group 1, so that forms a 1 plus ion. So we're going to need 2 of those to match the carbonate ion and make that electrically neutral, and we're told that is a solid. Then we need hydrochloric acid. Okay, HCl, AQ. Reacting to give. So we're going to get, this is an acid plus a carbonate, we're going to get a salt plus water plus carbon dioxide. The salt is going to be made from potassium and chloride ions. Potassium group 1, chlorine group 7, so that's going to be KCl. That will be aqueous. Plus some water, which is a liquid, plus CO2, gas. Let's check for balancing. We've got 2 potassiums over there, only 1 here. So we're going to have to put a 2 in front of there. That gives us 2 chloride ions over here. Let's put a 2 here. So now we've got 1 carbon, 3 oxygens, 1, 2, 3, 2 hydrogens, 2 chlorines, and 2 potassiums, so everything's balanced. Okay, in 3C we've got aluminium sulfate solution plus barium chloride solution. So aluminium, that's in group 3, so that will form a 3 plus ion. Sulfate is SO4 2 minus, so we're going to have to balance the charges on those by having 2 aluminiums and 3 sulfates. So 2 times 3 plus would be 6 plus, 3 times 2 minus will be 6 minus, and that's now electrically neutral. We've got that in aqueous solution. And then we've got some barium chloride, which is BaCl2, barium in group 2, and again that's aqueous. So what do we get from this? This is the test for sulfate ions, so we know we get a barium sulfate precipitate. It's BaSO4 precipitate, so it's a solid. And the other bits left over are aluminium and chlorine. Aluminium a 3+ ion, chloride a minus ion, so we need 3 of those to balance the 3+ charge. So do we have our equation balanced? I'm sure we don't. We've got 3 chlorines over here, 2 chlorines over this side, 3 sulfates, only 1 sulfate. Let's try putting a 3 there. So we've now got 3 sulfates. We've got 3 bariums here, only 1 barium. Change that to a 3. Now we've got 6 chlorine atoms. We need to put a 2 here. 2 aluminiums, 2 aluminiums. 3 sulfates, 3 sulfates. 3 bariums, 3 bariums. 6 chlorines, 6 chlorines. That all balances. So here we're on question 4. Write ionic equations including state symbols to show the reactions that help identify bromide ions, sulfate ions and carbonate ions. So in 4a, the reaction that will identify bromide ions is to add some silver nitrate and get that precipitate, creamy coloured precipitate of silver bromide. So we've got some Br- ions in our solution. We're going to add silver nitrate and make a silver bromide precipitate. So the nitrate is going to be a spectator ion. It ends up in solution. It starts off in solution, ends up in solution, so it isn't changed, and it's just a spectator ion. We can leave that out. The silver is the bit we need to add in here. So we've got some silver ions in aqueous solution, and we're going to make silver bromide precipitate. That's all there is to it for this one. Very straightforward. Got a 1+ charge on the bromide ion, 1+ charge on the silver ion, and so it's AgBr in the product, and everything is already balanced. Part B, identifying sulfate ions. So here we're adding barium chloride, and we're going to get a precipitate of barium sulfate. So we have some sulfate ions. There's our SO4 2-. We're adding some barium ions in aqueous solution, and we get this precipitate of barium sulfate. So SO4 2-, barium is in group 2, so it's going to be a 2+ ion, so they will form barium sulfate BaSO4, and that is a solid. Again, we have no balancing to do. We've got 1 barium, 1 sulfate, 1 sulfate, all nice and easy. Part C, the test for carbonate. So we know that acid plus carbonate gives us salt plus water plus CO2. Acid is going to be some H+ ions in aqueous solution. Carbonate, CO3 2-, again in aqueous solution. So this is going to give us the CO2 over here. We need some H2O and the salt is going to be made from whatever the acid is. So if it was, let's say, hydrochloric acid, we'll have some Cl minus, and let's say it was sodium carbonate, we'd end up making sodium chloride as the salt. But these ions are not changed by the reaction, they're just spectating, so we can cross them out. Whereas H plus and CO3 2- are changed by the reaction, so we need to consider what happens to those. So that's going to be a liquid, that will be a gas. So H plus forms H2O, it's taking the oxygen off this carbonate ion, leaving behind CO2. So in fact, once we've taken out these other spectator ions, that is all the reaction we need for this ionic reaction. We just need a bit of balancing. We've got 2 hydrogens over here, only one on this side. So put one there. 2 hydrogens, 1 carbon, 3 oxygens, 1, 2, 3 oxygens. We also electrically balanced on this side, everything is neutral, and over this side we've got 2 plus charges, 2 minus charges, so we're electrically neutral on this side. We've got to balance the number of atoms and the charges as we do these kind of reactions. So in the question 5, in the test for halide ions, explain why nitric acid rather than other acids is added to a sample before you add silver nitrate solution. So we're going to be testing for halide ions, which are those. We're going to add silver nitrate, which has those ions in it, and we're acidifying first with nitric acid, which has these ions in it. So let's think about what would happen if we added hydrochloric acid. Hydrochloric acid is made up of H plus and Cl minus ions. So we'd be adding some Cl minus ions and then adding some silver nitrate. We'd always get a precipitate, a white precipitate of silver chloride, because we've used the wrong acid. So we can't use that one because of its chloride ions that it contains. If we used H2SO4, we've got some sulfate ions that we're introducing. Sulfate ions would react with the silver to produce silver sulfate precipitate. So we can't use that because that would suggest that we had some chloride ions and we didn't have any present. So by using the nitric acid, we can minimize the number of extra ions that we introduce. We've already got some nitrate ions from the silver nitrate. So this is the best one to use, tick. Why do we use it? Well, we want to use this acid to get rid of any things like carbonate ions, which might be around. The acid would react with the carbonate. To give us H2O and CO2, but no precipitate. So this acid gets rid of any carbonates that might be present, doesn't precipitate anything out. If carbonate was present with the silver, we'd get a silver carbonate precipitate, and again that would interfere with our test. So we use nitric acid to acidify before we put in our silver nitrate, and that means this is a good test for these 3 halide ions.